we'll see the IUPAC nomenclature of ethers. Now it should be realized that ethers are named as alkoxy-alkane. We have to name them as alkoxy-alkane. This is the naming system in IUPAC name. Now we've taken two examples here to study how the ethers are named. Now first, when you have the structure like this, you will notice that on one side of oxygen you have alkyl group, and on other side also you have another alkyl group. In my first case, you will find that the two alkyl groups are same. So you will combine oxygen with one alkyl group. So this is alkoxy. Alkyl group with oxygen becomes alkoxy group, and other becomes the alkane group. Other carbon and the chain becomes alkane. Now this compound will be called as methoxy. This will be called as methoxy and methane. This is methoxymethane. The reason for this is oxygen with one carbon, so methoxy, and methane because remaining other alkyl group has only one carbon, so this will be called as methoxymethane. Come to another example. The next example, you find that see the two groups present on both the sides of oxygen. One group has only one carbon, other group has two carbons. So the smaller group you will combine with oxygen, and this becomes the alkoxy group. So alkoxy group is your methoxy group. This is methoxy group, and the remaining group becomes the parent alkane. Remaining group मध्ये किती carbons आहेत? 2 carbons. So this becomes methoxy and ethane. This becomes the IUPAC name of the compound. So this care you have to take whenever you are writing IUPAC name. Combine the small alkyl group with oxygen and name it as alkoxy, and remaining number of carbon becomes the parent alkane. So let's see some examples. Now you have here this compound where on one side you have a smaller number of carbons, only one carbon, and on the other side you have 3 carbons, 1, 2 and 3. So the compound will have common name as, common name देताना काय करणार आपण, मिथिल, and दूसरा group काय आहे, N-propyl, 3 carbons, N-propyl because all are present in a straight chain. So methyl N-propyl ether becomes the common name of the compound. Common name is easy to give, and IUPAC becomes methoxy and propane. Other this is propane. Propane मध्ये when you number the carbons, this is carbon number 1, 2 and 3. So compound becomes 1 methoxy and propane. Come to the next example. In next example, you have on one side of oxygen you have 2 carbons. This is C2H5. So CH2CH3. So you can write this as CH2CH3, CH2 and CH3. So 2 carbons present here. On the other side you have 3 carbons, 1, 2 and 3. So this will become the parent alkane, and other you will combine with oxygen. So while giving IUPAC name you will do it, but when you are writing the common name देताना oxygen च्या दोन्ही side ला groups पहा. One is ethyl group and the other group that comes is isopropyl group. So you will name the compound as ethyl isopropyl ether. Isopropyl word का आला because you will find carbon has this shape, this L form. It's iso, branched आहे. Chain च्या second carbon ला branching आहे. This becomes isopropyl ether. Now to give its IUPAC name, you will call this as ethoxy. This is ethoxy group along with propane. आता parent chain ला numbering करा. This is carbon number 1, carbon number 2, carbon number 3. So this becomes 2-ethoxy and propane. Next example. In next example again, common name becomes methyl phenyl ether. See the two alkyl groups. This is alkene, this is aryl group. So methyl phenyl ether, and the IUPAC name becomes, this is a bigger group, this is the parent. Smaller group is alkoxy, that is methoxy. This is called as methoxy benzene. In another example, next example, you have the two alkyl groups as, you have one as phenyl group, other is N-propyl. All propyl, 3 carbons present in straight chain, N-propyl. So you will call it as phenyl and N-propyl ether. Phenyl is a pH हा आधी येणार अल्फाबेटिकली अँड PR प्रोपिलचा PR हा नंतर येणार. सो फेनिल N प्रोपिल इथर अँड द IUPAC name of the compound becomes, this is 1-propoxybenzene. 1-propoxybenzene will be the name of the compound. Now we'll go for preparation of ethers. Ethers can be prepared by the methods, following methods. First method is called as dehydration of alcohols. Dehydration is removal of H2O from alcohols. What are the reagents required? Of course, concentrated H2SO4 or phosphoric acid. Concentrated H2SO4 or phosphoric acid act as dehydrating agent, so they are used in the reaction. The very important part of the reaction is if the temperature conditions of the reactions are changed, you get totally a different reaction. Now this reaction was there in this year's board examination, that is in 2020 students have written this reaction. So what do you find? At 413 Kelvin, two molecules of ethyl alcohol when heated at 413 Kelvin in presence of concentrated H2SO4, there is formation of ether which is called as ethoxyethane. So simple to name, both the ethers are of the same type, OC2H5. This becomes ethoxy and two carbons ethane, ethoxyethane and H2O. Two molecules of ethyl alcohol are reacting here to give C2H5, OC2H5. राहिला काय 2H and 1 oxygen gives H2O. Now if the reaction is very easy here, if the temperature conditions are changed, in spite of taking it as 413 Kelvin, if the temperature is 443 Kelvin, then see the reaction. Ethanol at this temperature in presence of concentrated H2SO4 forms ethene along with H2O. The ethanol molecule, या molecule madun H2O goes, H, one more H from here and O, they go out and you have formation of C double bond C. Ethene is formed in the reaction. So here the temperature condition is very important. We want to prepare an ether, म्हणून आपल्याला the required temperature condition must be 413 Kelvin, and if the temperature rises and reaches 443, the reaction will not form the expected product. म्हणून this is very important reaction. Second preparation method is by Williamson synthesis. Williamson synthesis मध्ये we are treating an alkyl halide with sodium alkoxide. Alkyl halide is treated with sodium alkoxide. हा आपण आधी पण पाहिलेला आहे in halogen derivative. The reaction that is seen here, written here, is ethyl bromide when treated with sodium ethoxide. Sodium ethoxide C2H5ONA is sodium ethoxide. आता फक्त लिहिताना it is written as NaOC2H5. It forms the products. काय काय product form होणार? Here there will be loss of NABR. NABR will be lost in the reaction and you will get formation of C2H5O C2H5 plus NABR. Ethoxyethane will be formed in the reaction. Now again we'll try to prepare an aryl ether. Aryl ether मध्ये काय आहे? You will get an aryl group. Aromatic ऑक्सिजनच्या एका साइडला aromatic ring present असेल, म्हणजे आपल्याला यूज करताना एक aromatic structure यूज करावा लागेल. So C2H5Br, ethyl bromide when treated with sodium phenoxide C6H5ONA. There is again removal of NABR. NABR goes out in the reaction and there is linking of C2H5O and C6H5, or you draw the aromatic ring. The compound is called as ethoxybenzene. Ethoxybenzene and NABR. Now we are taking a higher compound here. Higher sodium tertiary butoxide. Sodium and tertiary butoxide. When treated with methyl bromide, परत NABR will be lost and form काय होणार? All this group will remain as it is. This group remains as it is. This much group is remaining as it is, and it will combine with CH3. O and CH3 will be formed. So you get formation of tertiary butyl methyl ether. T-butyl and methyl ether will be formed here along with NABR. Now why I have given here important? See the colored part that I have written. That if you are using a secondary or tertiary type of alkyl halide, previous reaction मध्ये alkyl halide that was used was a primary alkyl halide. But if you use a secondary or a tertiary alkyl halide, you don't get an ether, but in spite of that, you get an alkene. So that reaction is here. T-butyl chloride. हा पण tertiary group कसा पाहिजे? Tertiary should be with ONA. Then you get ether. But इथे काय झालाय? Tertiary group or a secondary group when taken with halogen. That is, if you use a secondary or a tertiary alkyl halide like T-butyl chloride when treated with sodium ethoxide, you get formation of isobutene. Isobutene कसा फॉर्म होणार? Here NaCl बाहेर जाणार. NaCl will be going out. NaCl तर बाहेर जाणारच. या ग्रुप मधून या CH3 चा एक H बाहेर जातो and या कार्बन आणि या कार्बन मध्ये there is formation of a double bond between these two carbons. हा H बाहेर जाणार, हा Cl गेला. NaCl फॉर्म होणार, हा H रिलीज झालेला आहे. This is losing one H. Carbon carbon double bond is formed, getting formation of an alkene isobutene. जो H निघालेला आहे that combines with C2H5O and H to form an alcohol with NaCl. म्हणून what is important in the Williamson synthesis, that whatever tertiary groups we are taking, tertiary or secondary group, it should not be of halogen. तुम्ही अल्कोक्साइडचा घ्या, सोडियम अल्कोक्साइडचा घेऊ शकता तुम्ही, tertiary or secondary group. You shouldn't take for tertiary halogen. Secondary or tertiary halogen जे compounds use करायचे नाही, because they will give us an alkene in spite of giving an ether. So this is a very important point. This becomes a drawback. मला कोणी drawback विचारलं की what is drawback of Williamson synthesis? You can say that if a secondary or a tertiary alkyl halide is used, it does not give an ether, but in spite of that it is giving an alkene, which becomes the drawback of Williamson synthesis. You are expected to use, you are required to use tertiary group or a secondary group of sodium alkoxide. Sodium alkoxide चा tertiary or secondary group यायला पाहिजे. आपण जर हॅलोजनचा घेतला, हॅलाइडचा घेतला, secondary or tertiary alkyl halide, it will not give you the formation of ether. In spite of that, it forms an alkene. This is one of the drawbacks of Williamson synthesis.